Welcome to First Fuel, a podcast bringing you perspectives on the role of energy efficiency, energy management, demand response, and the energy transition taking place in Australia and around the world. I'm Luke Menzel, CEO of the Energy Efficiency Council, and this week I'm joined by two guests. First up, we have Paul Roosevelt, Professor of Energy and Building Performance at the University College London Energy Institute and Vice Chair of the International Energy Agency's Energy in Buildings Communities Program. Paul, great to chat again, and thanks for getting up very early to join us on the podcast. How are things going for you and your colleagues at UCL in London?
Well, very good to be here. They're going okay. It's very different, as you can imagine, and there's a lot of uncertainty. Students are very concerned about how things are going to operate, but there's been a massive effort to try and get online teaching going and get the other support services that are needed to support students. And fortunately, we've been able to carry on with research, certainly in our field, without too much interruption.
Sounds very similar to the experience of some of our tertiary institutions here in Australia. I think it's been a challenge around the world. And we're also joined by Carlos Flores, Director of the National Australian Built Environment Rating System, or NABERS, who with Stanford Harrison from the Commonwealth shares the job of representing Australia on the IEA EBC as well. Welcome, Carlos, and how are you doing? And of course, the critical question is, are you and your team back in the office up there in Sydney?
Thanks for having me, Luke. I'm personally doing great. I am working from home, as you can probably see. You can see guitars in my house in the background. And our team is mostly working from home, as are a lot of people in Sydney still. I think that this period has been, it's been challenging for everybody. I think for our team in particular, we do a lot of work together. So the collaboration is something online, is something that we've been learning and getting better at. And obviously, some things are working great and some things we kind of missed being together in the same room and that kind of connection that you can have when you see people. But I think the other challenge is that we work with people across Australia, and different cities in Australia are under very different conditions. We are all, we have all of you in Melbourne, you look in all the people that we work with, and we're, in our thoughts every day, but also people who work in cities like Sydney are also quite anxious about the situation here. And then we have other cities where there are, significantly less infections and life has returned to some level of normalcy. So it's a mixed bag. There are some interesting things that we're all learning this period of time, but also we are still in this, and we have a long way to go.
Yeah, we do have a little way to go. I guess there's a sense of optimism here in Melbourne. As we note, the 7-day average has been going down consistently for the last 7 or 8 days. We're very hopeful that continues and that there is some light at the end of the tunnel. But as you say, really different experiences in different parts of the country, but also a lot of support across the country, and we appreciate your well wishes, Carlos. So today we're talking about a topic you're both really passionate about, driving global collaboration on high performance buildings. And of course, each of you have a particular insight into this topic, given your respective roles on the International Energy Agency's Energy in Buildings and Communities Program Executive Committee. But before we delve into the ins and the outs of IEA facilitated research collaboration, I want to get a sense of where you're both coming from. Paul, you in particular have spent 3 decades focused on boosting the operational performance of buildings. What inspired your passion for this topic?
I guess there have been a number of things along the way. I trained as an architect back in the late 70s and was interested in energy in buildings as an issue during my education. And then when I came out and I joined practice, the practice had one of the first computer-aided drafting systems around back in 1980. And myself and another sort of junior architect were put to work on these computer-aided drafting systems, essentially cutting and pasting bits of details from previous projects and multiplying them up to produce 500-bed hospitals and various things. And I said to one of the partners one day, how do we know these buildings actually work? We're sort of sticking them together like a jigsaw from other bits of buildings. And, how do we know they perform in the way that we expect them to? And his response was, well, nobody's ever complained. which always struck me as a pretty inadequate response.
Mm.
Even back then, I contrasted it to the sort of feedback that other industries get on their products, like automobiles and just everyday household products, and the fact that that feedback goes into the design cycle, and the product improves over time. And it just seemed to me that that didn't seem to happen in buildings. So I left the practice about a year later, and actually went off to do some research again, went back into university. And from there, one of my first projects was to build a group of super insulated houses. And I was fortunate to actually get to go and live in one and monitor the performance of the others, along with some houses that were built to a sort of, the everyday standard of the time. And that was a real eye-opener. A very good experience for a fairly young and junior architect. So that's kind of where it started.
Was that your first exposure to that idea of thermal performance and what it could do for, I guess, quality of life and amenity and affordability of homes?
I suppose, yeah, pretty much in practice. I mean, I got the first job in the university because they were interested in window insulation systems, and I designed and built my own sort of set of insulated shutters for the apartment I was in at the time. And that was kind of the first practical exposure. But yeah, the monitoring the super insulated houses was the sort of major one, if you like, the one that really got me into this whole business, and was the first experience I had of the performance gap, the difference between what we expect buildings to do and what they actually do in practice.
And do you think that that feedback loop between design, performance, and then the iteration of design into response to actual how buildings are performing in the field, has that improved over the last 30 years?
I think we've got a lot better at gathering the information. We have a whole better set of tools. I think the process of analyzing and assimilating that information is still far from well-oiled. It's a bit of a clunky process, and sometimes the right messages get through, but it's more by luck than judgment most of the time. I think that's the bit that we really need to work on, is how we streamline that information coming back from operational performance to informing the design process.
Sort of translating the experience into practice as quickly as possible, Paul.
Yeah.
Well, Carlos, Neighbours and the Commercial Building Disclosure Program is one of Australia's big energy efficiency success stories, and you've been at the helm of Neighbours for a number of years now. However, you've also been very active globally, not just with the IEBC, but also driving Neighbours uptake in places like New Zealand and the UK. Why do you see this global engagement as an important part of your job?
Look, I think the answer is that energy in buildings is at the center of a lot of sustainability issues that define our era in our work in sustainability. And I think a lot of people in this webinar would know that buildings represent about 40% of global carbon emissions. And obviously energy consumption in buildings is a big part, the biggest part of that story. So if we want to tackle climate change, energy consumption in the building sector is a key part of that puzzle. But also, we also spend about 90% of our lives in buildings. So indoors.
Or 100% in Melbourne, Carlos.
100% in Melbourne right now. Hopefully we'll go back to 90% in the not too distant future. But it says even in normal times, we spend 90% of our lives there. And one of the things that, and so obviously buildings have a big impact on our health and our well-being. And one thing that we don't always think about is just what do we use energy consumption in buildings for? And the majority in most building sectors is actually to make buildings more healthy and more comfortable. We heat buildings in the winter, we cool them in the summer, we ventilate them, we lit them. So if to better understanding the way that we use energy and enhancing that is a key part of tackling a lot of sustainability issues that we work in. And the thing about that is that these issues are not an Australian issue. It's not a Sydney, Melbourne issue. They're global issues. There are a lot of really smart people working in Australia and overseas. And what do we do? How do we tackle this? How do we move faster? So to me, some of these international work on both on Neighbours New Zealand, Neighbours UK, Neighbours in Australia, but also the Energy in Buildings and Communities program is a way for people, and particularly academics in the IEA, to come together, to put their heads together, to share lessons, to join forces, to move faster. That's really what it's all about. And I think my role as someone who works in sustainability and at a national level in Australia is to help us become more sustainable. Well, academics have a beautiful role to play, and the more they can do and the more they can share with others, the fastest we're going to move.
And I suppose you're really sitting at that nexus, aren't you, Carlos, between government and industry and academia and researchers, and looking to do what Paul's talking about, make sure that the latest research and insights are reflected in the Neighbours system as quickly as possible, so that can then in turn impact practice and the kind of things we're rewarding through Neighbours ratings.
Absolutely. And you work in energy efficiency, Luke, and you're the head of the Energy Efficiency Council. And we tend to think about energy efficiency as an area where a lot of the technology that we need is being developed, which is true. But there's a lot of other aspects of research that are really interesting. Those technologies have not been adopted anywhere near their potential, even though people could make money on them, they're cost efficient. So there's a lot of research around, well, why is that not happening at the speed that it could be happening? What are the kind of policies that we haven't tried in the past or we should try in the past? What are barriers to action that maybe we haven't identified as barriers and we haven't tried to tackle them? So even though sometimes we think about research or just the technology side of things, but it's so much more than that. And a lot of the people working in the IEA EBC are working on all kinds of aspects around energy, not just the technology itself, but how it's been used, what are the impacts on health, not just in climate. And I find that fascinating. It's a lot of really smart people doing great work.
Impacts on health, the reasons why certain technologies or practices get taken up or don't get taken up, how you sort of design policy to encourage the take up of, as you say, cost-effective technologies that are going to help us do the heavy lift of addressing climate change. All these things are topics that the IEABC gets to, which is a fantastic segue, Carlos, because we do really need to unpack the role of the International Energy Agency's Energy in Buildings and Communities program, which I should acknowledge is a mouthful, so I'm going to call it the IEABC from now on. But it's an important acronym because it's really one of the engine rooms for global collaboration on high performance buildings. And we at the Energy Efficiency Council are big fans of the IEABC and its work. We've co-hosted our national conference with the IEABC not once but twice over the last few years. But I know we'll have listeners out there that haven't heard of it. Paul, you're the Vice Chair. I know this is just one of the IEA's technology collaboration programs. Can we maybe start at the bare bones basics? Can you take us through what a TCP is?
Sure, yes. And I think this is something that a lot of people aren't that familiar with. They may have heard of the International Energy Agency. They know perhaps its headquarters is in Paris. But of course, that's the executive. That's the organization that garners research and data from around the world and publishes annual updates and reports on the state of energy across the whole spectrum, from energy efficiency through to conventional forms of power and so forth. The technology collaboration program kind of sits on the side of the executive and addresses the challenge of marshalling international research in a way that enables the individual parts to add up to more than the sum of those parts. And there are a large number of different programs focusing on different aspects of energy use. There are about 10 or so programs working in the field of buildings, and the Energy in Buildings and Communities programs is probably the largest and most well established of those. But we have things like the Solar Heating and Cooling program, which relates to buildings, the programs on heat pumps, programs on demand management, and so forth. But the Energy in Buildings and Communities program was established back in the 70s, and it's always really thrived as an international community. it is something that is subscribed to at the national level by individual member countries, but is typically supported and operated through the research organizations in those countries, typically universities, but sometimes other organizations. And to some extent, it involves industry and manufacturing where that's appropriate. Within the EBC, we have a very active program at the moment. We, to date, have undertaken some 86 annexes, and we call them annexes, but they're projects to all intents and purposes. And those projects will typically involve collaboration from anything from sort of 3 countries, and 3 or 4 organizations, up to sort of 15, 16 countries, and it can be 30 or 40 collaborating organizations. And they're led by one individual within one organization who has the job of coordinating all that stuff, which is can be quite daunting. One of my colleagues runs one of the biggest ones, and it's coming to an end later this year. And I think he'll be very relieved, having spent 5 years taking it through its preparation phase, its operational phase, and then its reporting phase. But it's also been a fantastic experience, being able to develop research with colleagues from 15 countries around the world.
Is that building energy epidemiology? Is that the one you're referring to?
That's right, yes, yeah, Annex 70, as we call it. And that's a topic that we kind of introduced to the EBC from our own institution. We've been working on it for a little while. In fact, it was actually one of our colleagues in Australia who came up with the idea. We were thinking about the way that we develop research in the energy field, do demonstration projects, all that sort of stuff. And he was chatting to his wife one evening. She's an epidemiologist, and she said, well, that's kind of like epidemiology, but you don't do it very well. Because it sounds like all of your demonstration projects are heavily biased.
Are you willing to dob in who this Einstein was? Who had this eureka moment?
Yeah, it's a chap called Alex Summerfield. He's based up in Brisbane. He used to work with us here in London, and he moved back to Australia, where he's from. And yeah, we maintain a relationship with Alex. Yeah.
All right. Well, I guess the interest of all our listeners will now be piqued, Paul. So you better explain what building energy epidemiology actually is.
Okay. So, well, epidemiology is essentially the study of what is upon the people. That's the literal sort of origins of the word. But obviously, it's had its strongest association over recent times with health. But it doesn't actually have to be about health. It can be about anything. But in the context of health, it's essentially a tool that can be used to try and understand things like how viruses spread, how diseases spread.
Just to pick a random example.
Yes, precisely. Yeah. And the father of epidemiology went to University College London, as you might expect, of course. John Snow, who back in the mid-19th century was the very famous chap who identified the source of the cholera epidemic in London. And he nailed it down to a particular water pump in the center of Soho. And he did this by using some classic epidemiological techniques. He basically studied the population. He tried to understand, because at the time it was thought to be spread through something called the miasma, the air. And he didn't trust that theory, so he started to do his own research. He surveyed people, what sort of things they had in common, what they didn't have in common. And what he discovered was that all the people in Soho drank water from this same water pump, or they fetched water in pails and so forth. But there were a couple of exceptions. There was a small brewery in the middle of the Soho, and none of the brewery workers had fallen ill. And that's because they drank the beer. And of course, the beer effectively purified the water. or the process of producing the beer purified the water. And then there was a couple of people outside of the area who had actually contracted the disease. And what he discovered was that these people's maids had been going to this particular water pump, which was a little bit further away, and bringing the water back to their houses. So that was a sort of basic study involving, understanding what's happening in the population, understanding outliers, and putting together a story. And he very famously went along to the pump and took the handle off it. And within a few months, the disease started to die away. So that's the kind of, and the other medical applications are very much around understanding how effective drugs are by doing various sorts of trials, double-blind trials, and so forth. And what we recognized was that in the field of energy, we weren't really having much by way of process around the research that we were doing in order to understand, say, for instance, the impact of new technologies or the design of new buildings, and that we were very much looking at things in an almost anecdotal way, with studies that were set up to find out what we wanted, or what we expected to find, rather than what we didn't expect to find, if you like. And also a lot of the research that produced sort of unhelpful information in terms of people's reputations and things like that is often not published and buried. And I was involved in the sort of mid-90s in the first attempt to try and change that by setting up a series of probe studies which were published in the Building Services Journal, where we went into buildings, carried out a systematic process of analysis, and then published the results of those analyses in the journal, alongside the original articles which hailed the buildings to be super energy efficient or whatever it was. We managed to do that without losing too many friends and without getting sued. And I think that was one of the things that paved the way to this more serious approach, a more methodological approach to energy research. We're not there yet, but I think the whole process of understanding energy performance in the population of buildings rather than just in individual buildings is being recognized now as something that we need to take more seriously at the national and subnational level.
So you've taken an idea that an Australian academic and his wife had on a couch. That's made its way to University College London, and then it's been translated into the space of the IEA EBC. And I understand, Paul, that means that you've effectively had researchers from around the globe sort of engaged in this process of formalising some of those methodologies and the way that we gather data and the way that we communicate data back into the community of building professionals. Is that kind of a good way of characterising that journey?
Yeah, that's pretty much it. And of course, it's not just data, it's models as well. So we're looking at the way that data comes in and is used in models, and then the results of those models are used in the process of making policy and so forth.
So, Carlos, I'm kind of interested in this life cycle because ultimately I think that our listeners will be interested in how it's impacting things on the ground here in Australia. So how does the insights that are being generated from something like building energy epidemiology actually change the way that you're doing your job as the Director of Neighbours?
Yeah, so that's interesting because Paul and I probably work at different scales in terms of data. We have a lot of data, but Paul often works with even more data and more granular. But I think that maybe one way in which this has influenced some of our work in Neighbours is that in the last few years we realized that if we want to, we're in a position to give a lot of statistical information about where the market is going, what are some key trends that are happening, it's very easy to take some small number of buildings and provide insights that are not real or that might be misleading, or they get proven not to be correct once you have a more representative sample of the population. So we've tried to do a lot more work on how do we systematically try to knock that those outliers out? What's a statistically significant population to show trends around? And that's one of the reasons, for example, look, why we still haven't released our figures for COVID-19. Like we do have data from when you do a neighbors rating, you have 12 months of data. We certify the majority of shopping centers and offices in Australia every year. But we have a little bit of a lag. So when you certify a neighbors rating today in August, you're probably using 12 months of data that ended maybe in July, maybe in June. So we have that delay, which means that it takes a little while for us to get enough data to show a trend. But secondly, once we have a trend, we actually want enough data to know that that trend is we can reflect it and communicate it to the market with confidence. It is not just that we happen to have a portfolio that is very active in sustainability and all their buildings were certified at once and suddenly they represent a third of the sample. That can happen and does happen with our numbers. So we are planning, for example, to release quite a bit of data on energy consumption, which by the way, we don't have explicit numbers just yet, but energy consumption does not fall with occupancy as fast as a lot of us would hope for, because a lot of buildings still run their lighting, they still run their air conditioning. Some people adapt better than others, some companies put more effort than others, but other aspects of sustainability like water consumption do drop significantly faster when people are not there, because there's no toilets, there's no potable water consumption. And waste has been even more dramatic. As soon as you saw people going into lockdowns in Australia, we saw a lot of buildings across Australia dropping waste generation on site by like 90%. A lot of those numbers are really interesting, but for us to be able to publish them with confidence, we want populations that are big enough, because that information is going to be used by the market. So it's got to be high quality information.
And I suppose where those, I guess, industry standards for high quality information and those expectations are starting to be shared across industry, then we can trust the data that's coming through a lot more, and it's much more likely that information is going to drive decision making in a productive direction. So I just wanted to unpack that life cycle, because I think it's really important for our listeners to kind of understand that the purpose of these programs that sit under the IEA isn't esoteric. It is really to ensure that we're not working within silos in countries as we're grappling with all these different problems, but that there's collaboration across countries, that the research is grounded and meaningful in different contexts, and then is disseminated as quickly as possible, right? And so I guess that's why, Carlos, you and Stanford Harrison from the Commonwealth have been sitting on the IEA-BC for the last 5 years? Must be coming up for 5 years, and I guess given how much you both have on your plate, you obviously regard it as a good use of your time.
Absolutely. I think it's a really important part of our work. And to be honest, look, I think I know we're going to get into how some of these analytics work, but I think the reason why I think it's so important is that we have a lot of unresolved issues in sustainability, a lot of areas where we need really practical research, solving a lot of problems and getting practical recommendations on what to do. What is the role of buildings in demand response? To what extent our buildings can be flexible? How do we complement that with renewables and battery storage, which a lot of us weren't thinking about 5 years ago, and now they're a reality. And we haven't actually had enough time thinking about what does this mean in terms of policy? What does this mean in terms of industry? What are some business models that are available that weren't there before? So there's a lot of thinking to do, and this is just a sliver of things across a lot of other topics. So I think it's really important that we do as much work as we can, and that's part of the reason why Stanford and I in particular have put quite a bit of time into this. That we're not experts on a lot of these topics, but there are a lot of really smart people in Australia who are doing great work on this, and that may or may not know that other people in other countries are also doing great work at the top of their game in a similar area, and that could help each other.
Oh, that's a fantastic example. Energy flexible buildings, another annex. I haven't memorized all the numbers, guys, so you can jump in and tell me which number annex it is, which I know is very important.
Annex 82.
There you go. I knew you'd know. But that's a stream of work. I know it's a new annex, but it's a stream of work that's been underway for a few years now, I understand, and super relevant in an Australian context. As we've just had, Paul, a reform to the way our wholesale electricity market works. We've introduced a wholesale demand response mechanism. There's a fair amount of understanding about how demand response works in the industrial space for energy intensive users, but I think it's fair to say, Carlos, that here in an Australian context, large property groups and building owners generally are still getting their head around, what their role might be in that space. I know our friend Bruce Precious has been doing some work for the Better Buildings Partnership on that very topic over the last little while. And so the fact that there is an existing stream of work through an organisation like the IEABC, which is specifically focused on how buildings can interact with those sorts of mechanisms, both at a single building level, but also at a portfolio level, but that's super relevant and something that we should absolutely be tapping into, right?
Absolutely.
And
Do you want to take that, Paul?
I was just going to say it's worth mentioning that annex doesn't come about from scratch. It actually feeds off previous annexes that have worked in that field, and this latest one is a refinement and advancement of ones that have gone before it. And we often find that that's the case, that the research programs roll on under a slightly different title with a slight change in the emphasis, or a big change in the emphasis sometimes, but often with the same people, but new people joining. Working in that sort of international context is quite challenging, and the themes like energy flexibility are general enough to be applicable across a wide range of different countries, different climates, different cultures, in fact. But obviously, many things in terms of energy use in buildings are quite country specific, they're quite climate specific. And therefore, I think more recently we've tended to focus on the subjects that are more around the methods that we use, and the analysis approaches we take, the design processes we take, but also covering technologies which have slightly differing applications in different parts of the world.
Well, luckily here in Australia, Paul, we have all the climates, so we're interested in it all. I think we've done a reasonable job of kind of explaining the IEBC and why the three of us are kind of interested and passionate about it. I just want to take a step back from that body and talk a little bit about the state of high performance buildings in general, do a bit of a pulse check on that topic. So Paul, when you look around the world, and you're obviously very engaged internationally, what has been achieved over the last 2 or 3 decades? And perhaps more importantly, what do you see as the big items on the to-do list for the 2020s?
Wow, that's such a broad question. What's been achieved? I think programs like Neighbours and the emphasis on understanding the performance of buildings in practice has changed very markedly. I think people now understand it as a subject. They're not always comfortable with it, but I think the progress that is being made is very valuable. I think the recognition that buildings don't always turn out as we expect them to, and that quite often in the early stages they need to be nursed and tweaked to achieve the performance that was expected, and then that has to continue as a sort of management exercise into the ongoing life of the building. I think those things are quite important. For me, they're more important than the sort of ultimate high efficiency building or the building that has all of the gadgets and gizmos and so forth, because actually my experience shows me that those are the buildings that fail, don't perform as you expect them to. The old principle of keep it simple, stupid is still one that's, I think, very credible in the context of building performance. But I think obviously as we in many countries have to decarbonize buildings fully, but they still need energy, then the real challenge is where does that residual energy come from? For us in the UK, it's the heat challenge. Heat is the single biggest user of energy, and at the moment it's all provided by gas, which is not renewable, and therefore we have to, and many other countries, have to think about how they move away from gas towards a decarbonized electricity supply, and that presents some really big challenges.
And how's that conversation going in the UK? Because I know there are certainly some people thinking deeply about that electrification piece in the context of the United Kingdom, the potential to move away from gas for heating needs to things like heat pumps. Is that something which is gaining momentum? And I guess the follow-up would be in the context of some of the announcements we've seen from a stimulus perspective from the Johnson government around upgrades to buildings. Is that idea of sort of moving away from gas being captured in all of that?
Possibly not directly in the latest announcements for subsidies of retrofits, but in separate programs, it's definitely being looked at. Programs looking at the effectiveness of different types of heat pump technology. Of course, we've also got programs looking at hydrogen and the extent to which hydrogen could be injected into the gas grid and used as a vector for renewable energy and so forth. So there are a range of things that are going on at the moment looking at that particular problem.
And is there a view emerging about the relative merits of electrification versus hydrogen in terms of decarbonising the gas grid, or is that something that's still very much in play and being debated within the UK?
Yeah, it's very much in play, and it's not clear to me that at the moment it's obvious how it will play out ultimately. There are obviously limits to the extent to which hydrogen can be used and generated and used across the existing gas grid, and it will involve a lot of conversion of devices or new technology being introduced. But that's not impossible, and it may be that we end up with a mix and match system where regionally there are some pockets of production of hydrogen, almost like the old town gas systems where it's manufactured locally or close to where a bunch of wind turbines are and then used in that region. I think it's probably going to be a mix and match solution, partly because if we depend on one technology, then there is small potential for risk and failure. And also, we may not be able to roll it out as quickly as we would be if we were able to use access and multiple technologies.
Look, I think that just to complement what Paul just said, I find this topic of electrification versus hydrogen a really interesting topic because it's becoming quite big in 2020. And there are a lot of people that work in building sustainability who are very strong advocates of all electric buildings, and to be honest, so am I. I think there's obviously electrification will be part of it, but I think is for all of us who work in sustainability, we want to keep options like clean hydrogen generated from water and renewable energy to be a potential solution for heating in the future. Because if it actually works out in terms of the technology exists, if it works out in terms of cost in the future, one option may be applicable to some use cases and the other one to others. But the challenge in sustainability, if you take it to first principles, is not that all buildings are electric. The challenge is that all buildings are decarbonized. And if that means that some of them end up using some hydrogen in some measure for specific purposes, I think that we all win if that actually turns out in the end. And I think if we work in sustainability and that's our goal, we need as many tools in the toolbox as we can. And if hydrogen works, I think that's great. And I do feel like sometimes when we're facing with a challenge, we need a lot of action really quickly, we have a tendency towards picking a winner. And I saw it a few years ago, just to make it very concrete, with cogeneration. we
Knew
wanted
what
to
you were
see
going
a
to
lot of,
say.
yeah, we wanted to see a lot of change in cogeneration, and a lot of people went all in cogeneration. And what happened in the end is that that was the right technology for some applications, but it was actually applied to a lot of things that were probably not the right use. And a few years later, we'll look back and went, actually, we learned from this, and cogeneration does work for these cases. And a lot of all this is not the solution. There are other solutions. And I suspect that that's what could happen here as well, that we might end up saying, you know, heat pumps and all electric cooling, in our case, Paul in particular, but also heating, but, you know, going both ways, full electric heating and cooling could work for a lot of buildings. And maybe when it gets complicated, when you need steam, or when you need, you know, depending on how it's used or depending on the external conditions, maybe the best option is using hydrogen, and maybe that can work. And I think all of us should probably keep in mind open to that, because if it's a combination, you know, the combination that delivers sooner carbon emission savings really is the one that is going to work best for all of us.
Yeah, I think you're right. I think the tricky thing around all of this is there's a lack of a clear framework from government at this point about what the pathway should be and to guide business decision making. And this isn't a comment on any particular government. It's just because the hydrogen conversation is so new. Like, it's really ramped up in the last couple of years. And the guidance that we're getting from places like Bloomberg New Energy Finance is the level of investment from government in Australia, at least, that would be required to really ramp up that hydrogen economy is you know, and orders of magnitude greater than what's currently on the table. And so I don't really have a dog in the fight, but I understand the perspective from, as you say, sustainability building advocates, that, you know, electrification, we've got existing technology, let's just get on with it. But it is really, it's something I've said on the podcast before, there's going to come a point where government's going to have to express a view on what the pathway is. Not to say that there can't be different options in different contexts, but we are going to have to make some choices of a nation about how we heat and cool our buildings and what the supporting infrastructure that we invest in for, you know, whatever the technology pathway we choose. And it's entirely plausible that might be different for different sectors of the economy and different in different countries as well, Paul, depending on the resources that are available. And of course, existing infrastructure should inform that, because, you know, there's risks around stranded assets that need to be managed and all of that kind of stuff. It's a swirling, heady mix with a lot of vested interests, Carlos. And in the end, we're going to have to make a choice around it as a society and as a community about what the appropriate pathway is in a particular context.
Absolutely. I think I have no doubts that all electric building would be the lion's share of that transformation, and it might be 100%, but it is possible that, and by the way, look, I also think that requires a lot of infrastructure in Australia in particular as well, because we don't have a lot of experience using heat pumps, and so there's a sector that we need to train. There are, you know, the ability to acquire the equipment that is needed at a lowest possible cost is quite early in Australia. So we need to go all in on that, absolutely. But all I'm saying is we shouldn't close our minds to the possibility that, you know, completely decarbonized fuels could be part of the mix in the future. And if so, I think that would be good news.
Absolutely.
I mean, I think when it comes to investment in hydrogen, you also have to think about the investment that we would need to make into electricity grids around the world if they suddenly had to take the whole strain. And in countries where we already have distribution systems for gas, then it makes sense to look at spreading the load as much as possible.
Yeah, and the other argument I've heard in that context is around spreading risk across grids effectively. So if we were to electrify everything, you've effectively, to some views, reducing the resilience in your energy system, because you're relying entirely on one energy source. So we could do a whole podcast just on electrification versus hydrogen, or how they can happily coexist, gentlemen. But we should move on. Carlos, Neighbours is kind of at the bleeding edge of the discussion about what's next for building sustainability in Australia. The discussion we just had, it's kind of demonstrated that. The IAEBC has all these research areas running simultaneously, as Paul has said, through the various annexes. What are the couple that stand out to you as really crucial for Australia right now?
So I can pick a couple, look, but I want to preface this with depending on what aspect of sustainability or buildings you work in, you will find interesting things at almost any annex for Australia, and it's partly because it goes into all elements of energy in buildings. So there's a couple of them that are very, very focused on very intensive heating that the applications to Australia might be a little bit more limited than the others, but most of them are very universal. If I had to choose two, I'll probably choose the energy flexible buildings that I mentioned before. What I like about it is that, first of all, it's relatively new. So there's a lot of the work is ahead of the annex. So if somebody would like to join right now, they could actually have a very meaningful participation for a long time in it. And they're going to be exploring the role of energy flexibility. Demand response could be another way of looking at that, but at the individual level as a building, but also at a precinct level, as a group of buildings in a district, and how does that combine with renewables and battery storage? I think that is a very, very relevant topic. And given that this is an annex that is building on another annex that just closed, that worked on that for the past 5 years. A lot of expertise there, but a lot of things have changed as well in the last 5 years. So I think it's a really fascinating topic. Another one is because I want to give a big shout to Stephen White from the CSIRO.
Yep.
It's Annex 81, which is the data-driven smart buildings annex. And really what they're doing is exploring the cutting edge of capturing, storing, and using data for better managing buildings. So it actually crosses the boundaries with a lot of things: energy efficiency, demand response, indoor air quality, but it's really focused on the data and technology. And the reason why I wanted to mention that is because I like the fact that it shows that some of these annexes are not only for academics. This one is a combination of people from academia, but also a lot of people from industry in Australia and also overseas. So it's a bit of a mix between researchers and also applied science. And I find that really interesting. Obviously, there's a lot more. There's annexes from indoor air quality in RESI to people-centric energy design, net zero or positive energy districts, so renewable energies at scale around buildings, and just a whole lot more. So I think I don't want to, people are coming from many different backgrounds in a webinar like this, and there's a lot of things that are very interested in that. And if you're really interested in participating more internationally in these big research undertakings with a lot of really great, smart people, it's a really good idea to go in there and look at what's happening in those annexes, because they are people that want to work with you and they have a platform for it.
Yeah, that's a fantastic point. It's almost, we can't do really any of the annexes justice in the time we have together, but there's an awful lot of information on the IEA EBC's website. Now, I should also note that we're the Energy Efficiency Council are keeping track of the EBC work program and areas of relevance to Australia. So as well as the EBC's own excellent website, we'll also include a link to that page on the EEC website in our show notes. Paul, what about you? Are there things that are sort of emerging in the IEA EBC space that you're particularly excited about?
Well, I think the thing that I'm sort of most excited about is the fact that we've got new countries joining that are very important from the global perspective on climate change. So China has been a member for a long time now. We've recently had Brazil join, and India has been sort of on the margins with us for a while, and I'm hoping that they will formally join in the next sort of 12 months. And of course, the topics that are relevant to those countries are much more to do with the development of building stocks as opposed to managing existing building stocks, as is the case in a lot of the sort of Western developed countries. And that also ties in with the fact that many of those countries need substantial amounts of cooling or need to have their buildings controlled to moderate very extreme temperatures in many cases. And we've got a couple of annexes on cooling, on resilient cooling of buildings, on indirect evaporative cooling of buildings, which I think are increasingly important to these large emerging economies that are now beginning to join into the EBC.
Okay. So as regular listeners know, we record many episodes of First Fuel live so that people can jump in on Zoom and contribute questions in the chat. I've got a few questions here. I'm going to try and cover off a couple of them. I've got one from Donald, gentlemen. What would be the role of thermal energy storage devices like phase change materials in the UK or Australia in the near future? Do you see the uptake of PCMs increasing in the future? I might throw that one to Paul first.
Okay, so I first came across PCMs in my university research in the mid-70s.
Yep. So they're about to take off, are they?
That's right, yeah. They've been that latent technology in more ways than one for many years. I think there undoubtedly is a role for PCMs in direct building materials for a start, because as we will increasingly, I think, build buildings that are manufactured in factories and assembled on site, and in many cases those will be lighter weight buildings, then the addition of PCMs to plasterboard or other building materials to increase the thermal capacity where you don't have the weight or the density, then that's obviously got to be a viable solution for those types of buildings. And certainly in the UK, we recognize that we're building these more energy efficient buildings, but without thermal capacity and the potential for extreme heat in summers, then we may be building in some problems for ourselves. So, but I have to say, over the years, I've seen various experiments with PCM tiles and phase change material, large volume storage systems where stratification has been a problem. And yeah, it's still not obvious to me how, exactly what role they could play, but there undoubtedly are some niche areas that they could fulfill a useful purpose.
Anything to chip in on that, Carlos?
I think Paul can cover the technical aspects of PCMs much better than me. But what I do think is that in the context of buildings nationally and globally needing to use less energy and reducing as much as we can, again, I think I'm personally very fortunate that we get to work with a lot of people and seeing a lot of people using all kinds of technologies to reduce energy consumption. I think the applications are different. I don't think there's one technology that you apply to all buildings and that's a winner and that's the problem solved. It doesn't work like that. Buildings are very complex machines, and every building, the mix of technologies to make that building as sustainable as possible is going to be different. But I do think that there's that aspect of seeing a lot of people experimenting in practice with building materials and with technologies to use less, as little low energy use as we can, is really important. So I think demonstration projects in Australian context is important. But again, at the end of the day, it's about using less energy use. I'd be really interested, by the way, whoever asked that question, to learn more about the application of PCMs in Australia. So whoever you are out there, our contact details are going to be here at the end, and we'd love to hear from you.
I've got another question here, Paul, from David, who is interested in what's going on in the apartment or flat sector in the UK. He says, I note that heat pump uptake for domestic hot water lags behind other European countries, but he's wondering if there's any areas that are showing innovation, I guess, in new build or potentially retrofit.
Yeah, that's interesting. I think the application of heat pumps in apartments and in the UK has been fairly limited, and probably limited to small package systems, which are there to provide some top-up cooling in dense urban environments. The majority of heat pump trial applications has been in single family homes. But of course, you know, we recognize we're lagging behind on this. The application of heat pumps in other parts of the world is well in advance of what we're doing. And, you know, one of the reasons that we participate in things like the IEA EBC is to understand how others have applied these technologies so that we can develop them. We've had such a highly developed gas grid that, you know, this hasn't been something that we've needed to consider in the past. I think when it comes to apartments, we're also looking more seriously at district solutions rather than just individual apartment solutions. It's, you know, for a number of reasons, there's, you know, opportunities to put in the basic pipework systems and then switch around the different supply technologies. And you know, as they evolve and develop over time, and I suspect that's one way that we might go. But of course, you know, all electric buildings with individual heat pumps in apartments is a possibility. I don't see it as a big market in the UK at the moment.
Paul, I think the heat pumps is, for in the Australian context, such a good example of the value of the EBC to me. So there are people in the EBC in countries like Denmark, for example, who have done a lot of work on heat pumps and who are really leading the world in developing that industry and applying it to buildings. And the thing about it is that there are a lot of things to learn from them, because particularly in things like capacity development, training, where it's working and where isn't. But there are a lot of things that are not as applicable. For example, the climate is a lot colder and the operational conditions in Australia would be quite different. So that is an aspect of application of heat pumps that could use a lot more research and a lot more, you know, what is the right application, how to do it well, how do we upskill our industry for this climate, that there's still a significant gap and a lot of people are working on that. But that's an area where we could learn from them, but also contribute to how do we expand heat pumps on climates that are more temperate, which there are a lot of countries in that field, not just Australia. And most of them are actually outside of Europe. So it's a really good example of both how to learn from another country and how to contribute to that field.
Well, we're just about out of time, but thank you both for a really fascinating conversation. I think one thing will be clear to all of our listeners: high performance buildings, they're also healthy and cheap to run and are an absolutely crucial component of the broader energy transition. And can I say, it's just fantastic that I know there are committed individuals like both of you breaking down the silos between countries and putting your own time into driving global collaboration, because we'll get further faster by working together. And here's hoping we can continue building momentum.
Thanks for having us, Luke. And thanks for everybody for being here.
Yes, thanks very much for listening, everybody, and thanks for the invitation to participate.
All right. Well,
talk to you, Carlos.
That wraps up this episode of First Fuel. If you have comments, you can find us on Twitter. Carlos is at Carlos Flores Len. Paul is at Paul Roosevelt, and my handle is at Luke Menzel. To keep up to date on the latest in energy efficiency, energy management, and demand response, you can follow the Energy Efficiency Council at EE Council. If Twitter is not your thing, you can find all of us on LinkedIn or email the team. The address is firstfuel@eec.org.au. Make sure you never miss an episode by subscribing to First Fuel in your podcast app of choice. And we'd love it if you could leave us a review and a rating on Apple Podcasts. It will help like-minded energy geeks find the show. And of course, many episodes like this one are broadcast as they're recorded, so you can jump on Zoom and listen in live. For a full listing of upcoming recording times, visit eec.org.au/podcasts. But for now, it's goodbye from us, and we'll catch you soon.